Hi class, it's Miss Meg here. Welcome to your first online class. As we mentioned in class, what the purpose of these videos is for you to have a background knowledge before you come into class this week. And later on in the semester, if you ever want to use these as study tools, we welcome you to do that. Alright, so let's get started. Today we're going to be talking about points, lines, and planes. But before we get started with these notes, we want to establish a few norms. So what you'll see here is something I just explained a little bit. Basically, the purpose is for you to have some background knowledge so that we can maximize time in class for these tougher problems. So what you're primarily going to be doing in these online classes is taking notes on definitions, theorems, postulates, and basic computational problems. So some norms is that we do expect you to take notes on a lined sheet of paper. We will go over what your notes should look like, basically how you should head them, how you should set up any graphic organizers, and what we do expect is that you keep these notes organized in chronological order in your binder. And the beauty of these videos is that, unlike in class when you may have missed something or something just doesn't quite make sense, you can't always just pause, rewind, and repeat me, but with these videos you can do that. So if there's anything that seems unclear or you happen to zone out for a few seconds while you're writing, feel free to just pause, rewind, and repeat the video as needed. So why does today's lesson matter? Today what we're going to be talking about is vocabulary for the first unit. And a lot of these words you will have definitely heard of and you could probably define in your own words. What you probably don't necessarily remember is how to precisely label and refer to these different geometric figures. So that's what we need to do, is so that we need to get everyone on the same page so that we can all have intelligent conversations in geometry and know what each one of us is talking about or referring to. So for each word, what you're going to learn is what it is, which is probably going to be pretty self-explanatory for a lot of these terms, how we label it, and what it looks like. Alright, so our first term is going to be a point. And what you can do is you can actually create a table, and I'm going to show you what this table is going to look like. Alright, so let's see, so here's my paper. Drawing an example for you. Here's your notebook paper, and what I want you to do is, at the top of the notes, label it Unit 1, Section 1.2. Okay, I apologize for my handwriting. In the top right corner, I want you to draw a 1 with a circle, and what you're going to do is you're going to draw a little table, alright? And it's going to have 4 columns, so column 1, column 2, column 3, and 4. In this far left column, it's going to say term. In the next column, it's going to say definition. So I abbreviate that def. In the next column, it's going to say label. So how do we label these different terms? And then in the far right column, it's going to say picture. Okay? Alright, and just have this table extend most of the way down the page. Don't worry about drawing in rows yet, just once you finish a term. So for example, that first term is going to be point. Once you finish filling it in, you can just draw a line like that and continue with the next term, okay? All right, so back to point. So what it is, it indicates a location and has no size. I'll give you about 20 seconds to copy that down. All right. And a point, how it's labeled is it's labeled with one capital letter. In the left-hand side of the screen, you're going to see this. We have this point, and we've labeled it capital A. All right, and in the far right column, you can obviously draw your point A. And right here, we see point A and B. This is just another example of points. And I wanted to show you that because I wanted to show you that you can name a point with any letter in the alphabet, A through Z, as long as it's a capital letter. All right, our next term is going to be a line. Definition for a line is that it's a straight path that extends in opposite directions without end and has no thickness. What you probably want to underline is without end. I'm going to underline it for you, without end, and has no thickness. Okay, so without end, it has no thickness. Just like we said with a point that has no size, lines have no thickness. So unlike in art class where you can draw thin and thick lines, in geometry we're just going to say that all lines have the same thickness and that they have no thickness. And without ends means that basically they're never ending. They go on forever, meaning you cannot actually measure a physical line. All right. So, and this is just kind of illustrating this again because it goes on forever. There are infinite points on a line. All right, just another. Okay, so how we can label it? We can label it in two different ways. Either we can label it by any 2 points on the line, and what we want to do is we want to take those 2 points on the line with their capital letters, and we want to draw a double arrow overhead. So this line could either be line AB or line BA. Another way we could label this line is just by any lowercase letter. So right here we have a lowercase m. This line can be labeled line M. So these are your 3 ways that you could label this line. All right, a plane. So a plane is a flat surface that extends without end and has no thickness. So again with the never-ending size and no thickness, the same is true for a plane. You see right here we've drawn kind of what we think a plane would look like, except that we know that obviously a plane isn't going to be like this parallelogram with its clean lines and border. It's actually just going to expand on forever. So we couldn't technically draw a physical plane, but this is what represents it in geometric diagrams. How we label it, there's a multitude of ways to label a plane, but basically you want to label it with at least 3 points on the plane that do not all lie on the same line. So how to label it? Okay, well, you can label it that way. So you want to have at least 3 points on the plane that do not lie on the same line. Or you can label it with a capital letter that is not a point on the plane. So what we see here is we've got 5 different letters on the plane. And we see that points A, M, T, and H all refer to points. And then P is just sitting out here on its own. So one way we could label this plane is by point P. Okay, so this is plane P. Another way we could label this is by 3 of the points that are not on the same line. All right, you could see that you can never connect A, M, and T with one line, and so they're not all contained on the same line. So you can label this plane AMT, plane MAT, or plane TMA, or any variation of those letters. You can also use point H in the mix, so you could say plane MAH or HAM or HAT. All right. And the next term is a segment, and a segment is a part of a line that consists of 2 points, 2 endpoints, and all of the points in between them. So unlike a line that went on forever, a line segment actually stops. And that allows us to measure it. So what we're going to be doing in later classes is actually working with different measurements of segments. All right, and how you label it is very similar to a line. You take the 2 points that are the endpoints of the segment and you put a little bar over top. So very, very similar. So this could have been segment AB or segment BA. All right. Next term is a ray. It's a part of a line that consists of one endpoint and all the points on the line in that opposite direction. So we see here that we've got endpoint A right here and another point B, and the ray extending forever, as indicated by this arrow, past point B. Okay. How it's labeled is a one-sided arrow where the arrow is over top of the letter in which direction the ray is pointing. So we said right here our endpoint's A. You're going to see basically what it looks like is a ray going from A through B and then on forever. And then down here, this is what ray BA would look like, is that it starts at endpoint B and it extends forever towards A and then finally past A, going on forever. Now, opposite rays. Opposite rays are 2 rays that share the same endpoint and create a line. So what we have is we've got ray CB, so it start at endpoint C and extend forever towards B. And then we also have ray CA, and ray CA extends in the opposite direction as ray CB. There's actually not a way to label opposite rays. You just have to kind of refer to them in a phrase or a sentence, like opposite ray CB and ray CA. Okay, so there's no specific real symbol. You just use the same symbols you were using for raise. Okay, so underneath this little table, we've got a couple vocabulary words we want you to take down. So there's some guiding questions up here. So what does coworker mean? Coworkers are two people who work together. And what does it mean if people co-found a company? It means they found it together. So the prefix co means together. And the two words we want you to write down are collinear and coplanar. And we want you to get these definitions down. That a collinear means that something lies on the same line. So together on the same line. And when we're talking about collinear, we're going to be talking about points. Okay, primarily points. Points are collinear. When we're talking about coplanar, we mean that two things lie in the same plane. All right, and when we're talking about coplanar, we're talking about both points. I'll go down here. Both points and lines. Okay, so points can be coplanar and lines can be coplanar. All right. And then another vocabulary word, a postulate, is just an accepted statement of fact. So just remember, write this underneath the table. You don't need to necessarily put it in the table. You just have to write it somewhere on your paper so that you can go back to it and refer to it later when you're studying. All right. Intersection, and finally the last term before we get into the last bit of the notes. But basically, intersection is when you have two or more geometric figures. The set of points of the figures have in common is their intersection. Okay? So this is your definition. All right, there are four important postulates about intersections. So what you're going to be doing is you're going to be actually drawing in a minute. So what we need to do first is turn your notes over and divide the back of your paper into 4 boxes like the one shown below. All right, you're going to put one of the 4 postulates in each of these boxes. So what's going to happen is that this box is going to be postulate 1, this box will be postulate 2, this box will be postulate 3, and this box will be postulate 4. Okay, so postulate 1. Through any 2 points, there is exactly one line. So what you need to do for this postulate is you need to copy down this statement and then draw this picture. So what we have in this picture is we have 2 points, point A and point B, and we have a line connecting them, line T. All right, and basically what this is saying is that you can't really, there's only one way to connect 2 points, and that's a line. And it's exactly one line. Okay, your second postulate is postulate 2. If 2 distinct lines intersect, then they intersect in exactly 1 point. This statement may be a little bit confusing at first, but it should be pretty self-explanatory after you look at the picture. You all have probably worked with intersection many, many times, and you see them in traffic, on maps, when 2 roads intersect. Basically, what we're saying is, line AE and line DB intersect at this 1 point C. All right, and the same is true for line segments. Okay, so say we weren't actually dealing with lines, we were dealing with line segments, the same would be true. Okay, postulate 3, moving right along. If 2 distinct planes intersect, then they intersect in exactly one line. So this is very similar to 2 lines intersecting, except that now we've added a second dimension. And because we've added this second dimension, or this actually, I guess technically this third dimension, we will have an intersection at a line. You might want to pause the video at this point because I'm going to keep going, but you do need to copy this diagram down, and it may take you a little bit longer. So by all means, copy and pause the video at this point so you can get this diagram down. You might want to trace it by putting your paper up to the computer screen. All right, in postulate 4. Through any 3 non-collinear points, there's exactly one plane. And this, you would have to know this to actually be able to label planes. So earlier in the lesson we said, you need to label a plane either by this point that's in the corner, so or this letter that's in the corner, letter P, or by 3 non-collinear points. You see that Q, R, and S can't be connected by one line. It looks like if they were connected, it'd be a triangle. So that means that these 3 points are not all on the same line, and therefore we are able to make